Assalamu alaikum dear students. My name is Asad Amin, lecturer in physics, Govt.Degree Boys College, Shah, Keamari. As you know that Sindh government has started a YouTube channel for students, and in this regard I am going to give you my second lecture on topic direct current generator from chapter number 14. Objective of the lesson. By the end of this lecture, the student will be able to describe the main components of DC generator and explain how it works. In this lecture, I will discuss with you the definition of direct current generator, principle, construction, working mechanism, and graphical representation. Now, the definition of DC generator is that it is a device which produces a unidirectional or direct current. This generator produces current based on fundamental of principle of Faraday law of electromagnetic induction. Now you know that the basic principle behind the working of AC generator is based on Faraday laws. The first law of Faraday says that whenever a conductor cuts magnetic flux, an EMF is induced in that conductor. Second law says that the magnitude of the induced EMF is equal to the rate of change of flux linkage. Now, to understand the working of DC generator, we should have a clear concept of Lenz's law, which says that an induced current always flows in a direction such that it opposes the change which produces it. As you see in the diagram that we are having a simple coil which is connected to a galvanometer and a magnet is moving towards that coil. Now when the north pole of the magnet is moved towards the coil, end of coil will become north pole, means it's following Lenz's law and opposing the cause of EMF, which is the relative motion of magnet and coil. Similarly, you see that in the second diagram we are moving magnet in the opposite direction. That is, when the north pole of the magnet is moved away from the coil, end of coil becomes south pole, so that it opposes its cause of motion, which is attraction. Now Fleming's right hand rule is also a necessary rule that we are going to apply on DC generator. As you know that in DC generator, whenever current flows across any conductor, we can apply the Fleming's right hand rule principle to find the direction of motion of conductor. So for that you have to stretch your right hand 3 fingers, that is the first finger, the middle finger and your thumb, in such a way that they are mutually perpendicular to each other. Now in this situation, the thumb represents the direction of motion of the conductor, the first finger or the forefinger represents field, the second finger or the middle finger represents current. Construction. The construction of DC generator is based on following components: field magnet, armature, split rings or commutator, and carbon brushes. Now I will discuss with you one by one the components of DC generator. So the first part or the first component is field magnet. It is a powerful electromagnet or permanent magnet. It produces a strong magnetic field in the region between its poles. The second component of DC generator is called armature. It consists of a rectangular coil having a large number of turns of insulated copper wire wound on a soft iron cylindrical core. It can be rotated in the magnetic field of the field magnet about an axis perpendicular to field. The third component of DC generator is called split ring commutator. The split ring commutator is mounted on the armature shaft but is insulated from it. The commutator reverses the connection of the coil to the external circuit each time the current reverses. The fourth component of DC generator are carbon brushes, which are acting as terminals. Two graphite or flexible metallic rods called brushes are lightly pressed against split rings. Through brushes, the current induced in the armature coil is fed to the external circuit by means of the line wire. Working. An AC current generator may be converted to DC current generator in couple of ways. Number 1. By using split ring commutator instead of slip rings. The split ring commutator is mounted on the armature shaft but is insulated from it. The commutator reverses the connection of the coil to the external circuit each time the current reverses. Thus, DC output is achieved from AC generator. Number 2. By using a bridge rectifier circuit. This is an arrangement of electronic component diode that convert AC to DC. So students, at your level we will not apply the second way, but we will go with the first one. Now it's very important to understand the graphical representation of DC generator. As you see that if you compare the graph of AC generator with the DC generator, then here there is a bit difference. In AC generator, because the current reverses its direction, so we were getting the negative peaks. But here, because the current is not changing its direction, so the output current is in the form of pulsating DC. More likely you can understand this by the first diagram, in which it says that in the first half of the revolution, current flows always along the armature ABCD, that is brush number 1, in contact with segment A. Now in the next half revolution in the figure, it's clear that the direction of the induced current in the coil is reversed, but at the same time the position of the segment A and B are also reversed, which result that brush number 1 comes in touch with the segment B. The current in the load resistance again flow L to M. The wave form of the current through the load circuit is as shown in the figure. This current is unidirectional. Acknowledgement. I would like to be very thankful to our Honorable Minister for College Education, Department Government of Sindh, Saeed Ghani, for giving us a chance to deliver our lectures on YouTube channel. Secondly, I would be very thankful to my principal, Professor Asghar Ali Channa, and the all faculty members of Govt.Degree Boys College, Jungle Shah Keamari, for their valuable support. In the last, I am also thankful to my son Sarib for giving me technical support. Thank you so much.